All right, so then we had a discussion and took this much further. We looked at four-sided objects, five-sided objects, six, and so on, and we discovered this, that for four-sided, always turns out that the angles add up to 360 degrees. For five-sided, it was 540 degrees. For six-sided, 720. Okay, and we could go on here further. And so one way we did this, some groups did, was they just looked at doing the same thing. They cut off the corners. Oops, let me pick a different color here. They, cut off the corners here, put them together, and they formed a 360 degree full turn. 540, you got 360 plus an extra 180. All right, but another way to look at this is to think of what we learned about with triangles, that triangles always add up to 180 degrees. So other groups tackled it like this. They saw that I could take this quadrilateral, slice it from vertex to vertex right here. Oops, that's horrible. Let's do that over. And get two triangles. So these three angles add up to 180, and then these three angles add up to 180. So it's basically just 180 plus 180, which got us the 360. I could do the same thing with the five-sided shape. I could start at, let's say, this vertex, cut off the top to create one triangle, go from that same vertex and cut through here to this spot, and then I get two more triangles. So one triangle plus two triangles plus three triangles, it's three triangles with 180 degrees apiece, and that's where the 540 comes from. And same thing if we continue with this pattern. Pick a vertex, start cutting triangles. There's 1, 2, 3, and 4. 2, 3, 4. So we get 4 times 180, and that's where we got the 720 from. So when we took all this information, looked at it as a class, we found these different patterns. So if we first listed the number of sides that our polygon had, we noticed that, of course, a three-sided shape, it forms a single triangle. But a quadrilateral, a four-sided shape, could be split into two triangles, five-sided into three, and so on and so forth. And so that if each triangle was 180 degrees, well, it was just 180 for each triangle. So two triangles, 180 plus 180. Three triangles, 540. Four triangles, 720, so on and so forth. So what we developed was this pattern. So let's say we call the number of sides n. N number of sides, any shape, 10, 100, whatever. That if you look here, the number of triangles in that shape is always 2 less than the number of sides. 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 3 is 3. 5 minus 2 is 3. 8 minus 2 is 6, so on and so forth. So we could describe the number of triangles inside a shape as the number of sides minus 2. And if this is the number of triangles in the shape, then all I have to do is multiply that by 180, and that gives me the sum of the interior angles. So we do 180 minus the number of triangles, and minus 2. And so what we developed was this formula. The sum of the measures of interior angles of an n-sided polygon, so for any number of sides, S is the sum. It's always equal to 180 degrees times the number of sides minus 2, because the number of sides minus 2 gives us the number of triangles.